those review questions. Okay, so we are going to talk about natural logs today, and natural logs have to do with E. And you guys may have seen this before in another class. This is really to do with continuously compounded interest, which we're going to talk more about on Friday. But this is a number like pi. It's irrational, it has no pattern to its decimal place, has its own special button on the calculator, but it's about 2.71828. If you keep looking at decimals, it goes on forever with no pattern to it. So E is just a number, and we're just going to practice evaluating it here really quick. So I'm just going to try to show you where the button's at on the calculator. Okay, so evaluate something means tell me a value. So I'm going to grab my calculator here real quick. Now, if you got a graphing calculator, the button you're going to use should be right to the left of the 4 key. It looks like an IN, but it's actually an LN. It's for the natural log, which we're going to actually use today as well. But if you look at that, the e to the x is the second function on that. So to do these questions, just hit second and then that LN button, and it should pop up an E for you. And then all you got to do is type in the exponent. So it's this 2.71828 long decimal, and we're going to take that to the third power. And this is similar to a lot of questions we've been doing. These have really long decimals in most situations. And so we're going to go 3 decimal places for rounding. So this is really just to make sure you guys can find this on the calculator. So e to the third is about 20.086 to 3 decimal places. If you guys just have a scientific calculator, that should have an E button as well, and it's probably on the natural log button. So look for LN. I'll be happy to come look at your calculator if you're not finding it. Okay, now, if I do e to the -4th, I just want to remind you, you don't actually have to write this or anything, but that would be 1 over e to the 4th power. So it's not going to be a negative number. It's just going to be a super tiny decimal. Negative exponent does not mean negative number. Now, when you type this in, just hit that second natural log button, second LN, and then make sure you use the negative key under the 3. Don't use the subtraction sign. The calculator does not like that. And this is a tiny decimal, 0.018. And then the last one, I know we talked about this in one of the homework questions, but just to remind you, the 1/2 power is the same thing as the square root, so you could do either one. I would probably do the 1/2 power. So I'm just going to hit second, that natural log button, and I'm going to be really lazy. I'm just going to type 0.5. I'm not even going to type 1 divided by 2. So this would be about 1.649. So just practice. Make sure you guys can find that button on the calculator. Anybody not see it? Okay, now here's the reason I'm showing this to you today, because we're going to use this. So what they call the natural log function is abbreviated, that is a letter L and an N. All right, natural log, I don't know. I used to say log naturel to myself because I don't know why the button's like that. But anyway, natural log function is ln. It literally just has its own special button. And what it is, the natural log is just a log with the base of e. It just has its own special key. So you won't have to do like a change of base or anything like that to do these questions on the calculator. It has its own special button. You've been pushing the second that button to do these powers, but natural log follows all the same properties of regular logs. So like the power rule here, the product, the quotient, all the ones we've been talking about for regular logs also work for natural logs. All 3 of those properties. Power, if you have product, that's like adding, we squish it together with multiplication. Quotient, if you have subtracting, you can squish it together with division. So it follows all these same properties. It just looks a little different in the problem because it's going to say ln instead of log. So all I'm going to have you guys do on these first couple questions is just remember the properties of logarithms, but we're just going to do them with natural logs instead of regular logs. So if you got a number out in front, I've got 2 times the natural log of 12 here. We're going to write these as a single log. And if you want to skip a step here, I'm going to write this out though. So this would be, the power rule would say that first term is the natural log of 12 squared. If you got a number in front, it becomes an exponent on whatever follows, minus natural log of 9. And just real quick, I'm going to simplify. 12 squared is 144, right? Now, if I want to further switch this into a single log, if I have subtraction, what should I do with the 144 and the 9? Do that. Okay, so all y'all have to do, and grab your calculator if you want to do this, this would be natural log 144 divided by 9, just one single natural log by itself. And that's actually a nice number, it's 16. That's all you have to do. Just condense to a single log just means write it as just one ln and then one thing following. All right, now, the one right next to this, I got some variables in here, but I'm going to be able to, on this one, I'm going to apply the power rule again to that first term. So I got 3 times natural log of x. That's really natural log of x to the third. And then I've got the plus natural log of y. So now I just got 2, so we're going to push it down to 1. If I'm adding between logs, what does that turn into if I put it together? Like, what should I do with the x cubed and the y? Multiply. That's all you gotta do. And we don't actually know what that is because we don't have numbers, so we would just leave it right like that. Natural log, bless you, x to the third y. Does anybody have a question? Okay, I got one more. Now, this one has 3 different logs in it, so this is important. You gotta apply the properties. You can apply the power property at any point. Like I've got a 5 here. I'm gonna put that exponent on the 2. Everything else, if you have adding or subtracting, when you put it together, you have to follow how it's set up in the equation as you read it from left to right. So let me just simplify this first one just real quick. This would be 2 to the 5th. Then I got a natural log of 3 minus natural log of 4. 2 to the 5th, if you guys remember, that's just 32. Okay, now, I have, following this, I have adding, so that's going to be a product rule. I also have subtraction, so that's going to be a quotient rule. When I put this together, you've got to apply it as you read it from left to right. So first thing I should do here, I've got the 32 plus the natural log of 3. I'm going to take and do 32 times 3. I have to do that first, figure out what that is. And then I have minus the natural log of 4. So then this whole thing would be over 4. So you got to do the multiplication first. That's going to give you 96 if you multiply that. And then you want to divide that by 4 after you figure out what that product is. So as a single natural log here, if you take, you can actually divide this here. This is going to give you 24 as your single natural log. Natural log of 24. Is anybody having a question about the log properties? Same thing, it just says ln instead of log. Okay. Now, here's what we did yesterday. Except we used logs, so today we're going to use natural logs. So the one thing to remind you here, the natural log, they're not going to write this in here, but it has the little subscript of e. And e is just a number, it's not a variable, it's that 2.718 number that was on the front. And this is going to be why I practiced the calculator with you on that button. To get rid of a natural log, just like getting rid of a log, we're going to convert this to an exponential real quick. So I'm just going to swing that base of e to the other side, push that 7 up in the air. You're going to get 3x equals e to the 7th. E is not a variable, it's a number. It's like pi. So it's got its own special little button. So we're just going to grab the calculator like we were doing on the front. Just hit second, that ln button, do e to the 7th. And then now what I was taking the natural log of there was 3x. So I just have to do one more quick thing to get my actual answer. We're going to take that and divide it by 3. I would just leave it right on the calculator screen, not rounding it multiple times, just divide it right there. And then these are going to ask you for 3 decimal places if it's not a nice number. So I got 365.544. These really similar to the question we were doing yesterday, super easy to check. If you guys just don't hit second, just hit that natural log button, and I'm going to do 3 times my answer. I got 365.544. Now, we rounded it, but it should be super close to 7. It'll probably be a little bit off because we rounded it, but you guys can see I'm getting like 6.99, a bunch of 9s there. Easy to check these. So just use natural log and plug in your answer for x, or whatever variable you might be using. Okay, now this guy here, what I would tell you to do first, we can apply the power rule. So like I could put an exponent on this, but I would actually not recommend doing that because then I have to take a fifth root. What I would actually recommend right there, I'm going to divide both sides here by 5. It's just less buttons to push on the calculator. So I would not apply that power rule there. I would divide by 5. Then you get the natural log of 2x. This is -3. That's completely fine. We're not taking the natural log of a negative number there. It's equal to a negative number. That's okay. Remember, the natural log is just a log with a base of e. To get rid of the natural log, just like a regular log, we're just going to swing this guy over here, push that -3 up in the air. Now, e to the -3 would be 1 over e to the 3rd. So it's just going to be a super tiny decimal. I'm just going to do this on my calculator, though. So I'm just going to hit second and then that LN button. That'll give me e to a power. I'm going to type in the -3. Make sure I hit the negative key. Nope, hit the subtraction sign. Done like that. Hit equals. And then ultimately here, that my exponent, or what I was taking the natural log of was 2 to the x. So I do actually have to take what I just got and divide that by 2. And so my answer would be 3 decimal places, 0.025. Does anybody have a question? Okay, now the last one, there's 2 different ways you could do this. I have natural log 2x minus 4 to the 3rd. Here's what I would actually recommend here. I would take that 3 and I would actually reverse the power rule here. I would actually put that down in front, and it's just going to save me having to take a cube root. That's all I'm trying to do here. I'm going to put that 3 down in front real quick. If you have an exponent on a natural log or a log, you can put that down in front of the log or natural log by multiplying it out in front. And then instead of having to take a cube root at the end, I'm just going to do this real quick. I'm just going to divide by 3. And then I don't have to worry about that. So this would be natural log 2x minus 4 is equal to 2. Don't forget the natural log has a little base of e. We're going to get rid of the natural log from there by swinging this and converting to an exponential. This would be 2x minus 4 equals e to the 2nd. Now this is going to be one extra step than the other problems because what I was taking the natural log of was a little more complicated there. So I'm just going to do second natural log, type in 2 for my exponent, and then we are going to add the 4. So I'm just going to leave this right on the calculator screen. I'm going to add 4, and then I'm going to take and I'm going to divide that by 2 as my last step there. So I'm going to add 4 and divide by 2. And my answer here, 5.695, 3 decimal places. Does anybody have any question about any of these so far? Okay, now, example 4, these are exponential equations. So we did this a couple days ago. So what we did yesterday is really similar to the example 3, but this is from a couple days ago. And I promise these are actually easier than just a normal exponential equation because you're not going to have to do a change of base. You want to isolate e to the power here. So each one of these has e and then it has an exponent. So I'm just going to divide by 5 here real quick. This will give me e to the x. 55 divided by 5 is 11. Okay, I got to get my exponent down on the level with the rest of the equation. The only way to do that is actually to kind of reverse what we were doing in the questions above. I am going to change this to a log. All right, so base of my exponent, I'm going to drag that x down on the level with the rest of the question. The base of my exponent, which is e, becomes the base of my log. Now, I'm writing this out to kind of show this to you. But what I told you guys on the front, the log base e is just the natural log. It has its own special button on the calculator. So you're going to grab that button, and we just won't hit second here first. It's right next to the 4 if you've got a graphing calculator. So just hit natural log, type in 11, and you're done. That's your answer. So I'm going to go 3 decimal places here. This guy's going to be about 2.398. Super easy to check these if you want. I might check it like in the step where you have the e to the x by itself, but you could check it in the original problem too. Just plug that in for x, and it'll be a little bit off because we rounded it, but it should be really close. If you don't have the e by itself, like I had to divide by 5 here, we might have to do a couple steps on this one. So get rid of any addition or subtraction first. So I've got 4e to the 3x minus 8 equals negative 6. Add the 8 first. Get rid of any addition or subtraction first. 4 is not being taken to that power. It's just e to the 3x, so I'm going to divide by 4. All right, now, 2 divided by 4, right, is a half. And then my problem is my exponent has a variable in it, so I got to make that not an exponent. The only way to do that is to drag this over here, convert this to a log real quick. This would be your log base e of 1/2. Now, don't write that out if you can remember this. Log base e is just a special natural logarithm, so it has just natural log. If you want to not write the log base e, that's totally fine. I'm just trying to show you where I'm getting the natural log. And then I'm going to just do this on the calculator here real quick. We'll just do natural log button, put in a half, close the parentheses, or just hit equals, and then I'm going to divide that by 3. And this is completely fine. This is not going to cause you to take the natural log of a negative number to get a negative answer. X is representing an exponent here. Completely fine to have a negative exponent. And if you want to plug it back into check, you can. And then I just have one more. This has a little bit more complicated exponent. So I have e to the 8x over 5. I got to get rid of this 7.2 here to the side just real quick. So I have e to the 8x over 5, subtract that 7.2, that's actually just going to be equal to 2. Now this will be a little more complicated as we go through, but to get that exponent where my variable's at down on the level with the rest of the question, we just got to swing this over here to convert to a log, and then the exponential's down on the level with the rest of the question. So it'd be log base e or just natural log. Anytime you have a log base e, it's a natural log. What I'm going to do here, I'm going to do natural log of 2. I'm just going to hit equals. Now, I would, in that case, I have 8x over 5. So the next thing I would do, I would multiply this by 5 to get that out of the denominator. So I'm throwing things. I'm just going to take right on my calculator screen times 5. So then that would be equal to 8x. So then I need to, if I'm doing 8 times x, I'm going to divide by 8. And I'm just doing it right all on the calculator screen, so I'm not rounding multiple times. So then my answer here should be about 0.433. Any of these, you can plug them back into the original to check. Just put them in for x. It will be a little bit off because we only rounded to 3 decimal places, but it should be close. And then I have one more question. Okay, this is an actual legitimate formula for the currency. It says the value C, which if you look further into the question is in this lovely formula, is in billions of dollars, is for U.S. currency circulation 2000 to 2015, and that's the model for it. Now, T represents the year. Now, this is kind of important for the question. So it says T0 corresponds to the year 2000. So if I went through and did this problem and I got like t equals 50, that would be like 2050. Or if I got t equals 26, it would be 2026 would be the year. So T0 is the year 2000. So whatever we get for t, we'll just add that to 2000 to get the actual year. Okay, now it says solve the equation to find the year in which the value of the U.S. currency in circulation would exceed 825 billion. So C is in billions of dollars. This is what we want to put in for C. You don't have to put all the zeros because it says it's in billions of dollars. You're just literally going to put in 825. That's how much money we want to know when that amount is in circulation. Now, the other side of the equation is just going to stay consistent. Negative 451 plus 444 natural log of t. The most common mistake people will make on accident in this question is they will add this 444 and this negative 451. Do not do that. So the 444 is attached to the natural log of t with multiplication. So what you actually want to do here as your first step, we're just going to move 451 to the other side. And this is going to give you 1276. Okay, Then I would deal with the 444 by dividing that on both sides because I'm multiplying that by the natural log of t. Now, when I did this on my calculator, it was not a nice number. So I had like 1276. I divided by 444. I got some garbage answer. So I don't want to round multiple times as I do this. So I would just recommend, if you want to reduce the fraction, I could just do like math enter and reduce the fraction, or you could just leave it right like that. But I would leave it as a fraction here, or reduce it if you want to, just so we're not rounding multiple times. So I'm going to leave it like this. To get rid of the natural log, you got to remember it has a base of e. This would just be one step that you would have to do. To get rid of the natural log, I can swing that e to the other side, push that up into an exponential. E is not a variable, it's a number. So we can just do this on the calculator, e to that power, and that would give me the time. That time is going to be years after 2000. So I'm just going to do my second natural log to get my e, and then I'm just do 1276 divided by 444. If you guys have an 83, you might have to put parentheses around that. And so t here, it's about like 17.7 years. So if it's t is representing years since 2000, what year would this happen in? What do you think? If t is years since 2000, I got 17.7. What year would the value? 2017. Exactly. So that would be my answer to the question. In 2017, they had more than 825 billion in circulation. Does anybody have any questions? Guys, the next page in the homework packet should just be where the assignment's at.